Thank you everyone for coming to Mastering Android's App Resources. I know this is the last talk of today, so I really appreciate all of you coming here. My name is Yash Prabhu. I work for Warner Brothers Digital Labs, which was previously Drama Fever. So you can find me on the internet at Yash V Prabhu. I blog occasionally. The sample code for this talk is at my GitHub, and slides for this talk are on my speaker deck. So at Warner Brothers Digital Labs, we build a lot of media streaming apps. Drama Fever is one of them for international TV shows and movies, Boomerang's Cartoon Network, which was a joint venture with Turner, and Warner Archive, which is for classic movies. So today I want to talk about resources. These are some things that you've used a lot, because if you're an Android developer, the first thing that you notice on the left-hand side is all these resources are generated for you. And when you create an application project for the first time, you get these 4 standard ones: drawable, layout, map, and values. And there are some 3 simple values that are added there: colors XML, strings XML, and styles XML. But there's actually more to these resources. There's many more resource types. So on the left-hand side, we have the standard ones when you create your application project. But you actually have more of them. You have animator, which is for property animations and for custom views. And then you have anim, which is for view types, which is no longer used. And then for XML is what you would use for searchable configuration, something that you would write on your own, a custom XML. And menu is something you would use for context menu, options menu, something that you would inflate with your menu inflator. And draw files are for like arbitrary files. Color is where you would put your hex code. And font, which is something new in XML, and I'm super excited, new in Android O, and I'm super excited about it. So I want to give a quick primer on these resource types that you use. So you have drawable, which could generally be pings, SVGs, any sort of asset files, and you could also put select states in there. So if you create a selector and you want to create a select state for a button, if it's pressed, you want it to be a particular drawable. If it's not pressed, or the default state, you want it to be in a normal state. For layout is something that you would have in all of your apps. And there are plenty of different layouts types that you could use, like linear layout, constraint layout, and so on. And all of these go into the layout resource folder. And then you have maps, which are for launcher icons. And these get auto-generated for you when you first create a project, or you could speak to your designer and create assets that make sense for your app. Finally, we have simple values. There's more to it than just colors, strings, and styles. There's dimensions, booleans, integers, and arrays, and you can use this in a variety of ways that I'll be talking about later. So in your colors XML file, you create these resources. You just put the color and the hex code in there. And for your string files, you add text values. For your styles, it's for like all the styles and themes that you would add to your buttons or various other UI elements that you have. Dimensions is for things like padding, margins, and Boolean true or false values. And finally, integers for, say, you want to add number of columns or rows. You also have something called arrays, which we'll be talking about later. So there's a lot of things that I'm covering today. There's so much to learn about Android app resources. But here are some things that I just want to convey to you. I want you to know that there are a lot more resources than are originally created when you first create an application project, and that you can use these pretty effectively and wisely to design and build for multiple screens. And it helps you make your UI responsive, and it makes it easier for you to communicate with your designer or product manager who's like, why does it look like this on a phone but does not look like this on a tablet? And you can talk to them about it. And we're going to learn by example. So let's say your designer comes to you and says, here are the requirements. I want you to build a scrollable grid of items. It needs to have 2 columns in phone, 2 in portrait, and in landscape. So you're like, this is easy. And you imagine it to be this way. Here's a recycler view that I'm going to create. It's going to have like 2 columns, and it's going to have, it's going to scroll. And when I do the same thing in landscape mode, I'm going to put some margins on the side, so it's going to have 2 columns in both phone and in portrait and landscape. So you go to your resources in XML, you create a view grid item XML, you give it a style, a rectangle style, some background. You create a style, the rectangle style, which has all these dimensions, a width and height. So one thing that we do with dimensions where I work is that we create multiples of 2, And this is because material design lays out everything in a 8 dB baseline grid. So it's easier for us to lay those UI elements out. And then you access those resources in code, you find your recycler view, and notice that we're using the grid number of columns here, which is a static field, and you set that as 2. So there, you've done it. You've satisfied the requirements. You head back to your designer or your product manager. They're like, yeah, all that is cool, but I want you to support different layouts for phones and tablets, in portrait, in landscape. I want you to support locales. I want you to do this. I want you to do that. So first of all, it is scope creep. But when you're actually building something, you're not just designing for one device type, not just phone, not just tablet. You're designing for thousands of devices. And it looks like this. So this was something that a company called OpenSignal put out about 2 years ago about the variety of screen sizes you're designing for in Android. 24,000 devices, and this was 2 years ago, so I have no idea how much it is right now. You could just be like, hashtag MinSDK version 21, I'm not going to support anything lower than that, I'm just going to deal with issues on Lollipop and above. But sometimes you have to support, based on your client or your in-house product, you have to support devices that are lower than that version. In our case, we have to support MinSDK 16 in one of our apps because it's been in the market for 5 years. And there are a lot of our users who are international, and they use apps that are on Android 4.0. So even if you think that I'm not going to use this, it's 23% of devices, 23% of Android users out there are not going to be able to access your app. So that's something you have to decide for yourself based on where your app is used and what market share, what markets you're targeting. So you go back to your requirements, you have your designer tell you all this, and you're like, scratch all of that out. You just have to think of it not as devices, not as phones or tablets or screens, but you just have to think of different layouts for different breakpoints. And these breakpoints are not those breakpoints that you add in debugging. These breakpoints are what I interchangeably use with qualifiers, which are these numbers that we decide that this is a breakpoint at which I want my layout to look different. So let's talk about supporting multiple screens using qualifiers. Before I get into that, I want to talk a little bit about the terminology. So these are the qualifiers that we'll be using. Port and land for orientation, that stands for portrait and landscape. Screen size, which is the size of the device measured along the diagonal, ranging from extra small to extra large. Resolution is the physical pixels. And density independent pixel, or DP or DIP, is the virtual pixel. And screen density is ranges from LDPI up to XXX HDPI, and that is the ratio. And you can convert from pixels to dips using this formula. So it's 240 dp screen, which means 1 dp is equal to 1.5 pixels, so it's an HDPI screen. One more thing to note about is scale pixels, or SP. It makes sure that you preserve your user's font settings. So if you go to your Android device and then go to the display settings and font size and change it from small or normal to largest, not only does it change the text size on the settings app, it also changes the text size for all the apps on your device. So you need to make sure that you use SP and not pixels here, because your app's text views are not going to scale. One of the things that I really love, and I keep going back to this diagram, is in material design, is that it gives you an idea of how things are laid out and how you can support multiple screens. So if you look on the top, I don't know if this is clear from far, but if you look on the top, the highlighted section, these are those breakpoints that I was talking about: 0, 480, 600, 840, and so on. So for example, if it's breakpoint 480, that's the breakpoint at which my layout might look different. At 600, I'm going to create a different layout for it. We also have 4 columns, 8 columns, and 12 columns. That is basically telling you that if it's any device that has a width of 480 and below is going to show 4 columns. Columns is basically a concept in material design that everything is laid out in 12 columns. And if it's a 480 device, it does not have as much screen space, so it's going to show 4 columns. And if it's a device that is larger than 840, then it's going to show 12 columns. And then we talked about screen size measured along the diagonal that ranges from extra small to extra large. And finally, the orientation, portrait and landscape. So going back to material I/O devices, I talked about columns. So there are 4 columns for an Nexus 4 because it has a width of 364, which is lesser than 480. That was our breakpoint. And then when you rotate the device, it has a width of 640. Yeah, it's a width of 640, which is now in that 8 columns. That is control, yeah. So going back to our configurations and qualifiers, whenever you declare resource, you create a resource name and a configuration qualifier. So a drawable -HTTPI, layout -port -HTTPI, and so on. So there is something called a configuration and qualifiers table that is in the Android app resources that you can access. And it gives you an idea of what these qualifiers are. So you cannot just say, I'm going to call it layout -landscape. It has to be land, it has to be port, it has to be HTTPI. So now we can think about building a responsive UI on multiple screens. So I'm going to create a default layout called activity grid. And I'm going to create a layout for width 600 dp, which is for any device that has a minimum width of 600 dp. So in this case, I'm going to use width 600 dp. And on the right-hand side, you can see that in landscape, it has this image view right on top. So on the left-hand side, it's just a recycler view with scrollable items. And then on the right-hand side, it has an image on top, and it has a scrollable list. So basically, at the width 600 dp, the layout that is being picked is the second layout. If you didn't want to use width 600 dp, you would settle for using smallest width 600 dp. And in this case, you don't even have to create smallest width 600 dp because you're basically using the same layout. So what is the difference between the two? Why would I use width over smallest width? So width is actually based on the available width of the device, and it changes on orientation. So if you were moving from portrait to landscape, then you want your layout to change to this different layout, then that's when you would use width 600 dp. If you didn't want it to change, you just set it to smallest width 600 dp. So in this case, the Pixel XL has a width of 411. That's when it's in portrait mode, but when you rotate it, it's 731, and that width 731 is greater than 600 dp, so it picks the first layout here. Now, you could do the same thing with Nexus 7. Say your designer says, I don't want to have 2 columns on Nexus 7. I wanted to have 3 columns, but I wanted to have the same layout as width 600 dp. The first thought would be, I'm just going to copy-paste this and create one for layout 720 dp because that's the width of a Nexus 7. You don't have to do that. You find something that is common between these layouts. And in this case, the common thing is actually your recycler view. You're just changing the number of columns that you want to show there. So you can do this in a clever way. You could just go to your integers, the simple values, create a default integer file, which has the grid number of columns as 2. And when you have something like height 720 dp, you create a grid number of columns as 3. And now, when you go back to recycler view, you just access your resources, and then you set your integer value to grid number of columns. You access it directly from integers instead of setting a static field. And at runtime, the Android system knows the width of this device is, height of this device is 720. So at this point, I'm going to pick grid number of columns as 3, and it's going to show you 3. So you didn't have to create a different layout. You just basically had to change the simple values a little bit to do that. You can also do the same thing with locales. So again, for each of these things, when you're experimenting with different qualifiers, always make sure you have a default set. So the default for locales is always English, and then you can set your strings in Espanol, and you can set it in Hindi as well. So if you create a locale here, there's a bunch of information that I've put in here for default values. And then for Hindi, I've just copy-pasted from Google Translate. I don't know if it's right. I've also added this added this line, translatable equals false, which means, hey, Android system, do not translate this because I don't want this to be translated. So after you've done all that, you can see all this information here on the screen. All you have to do is go to your app's display settings and change the app settings, rather, and change the language from English to Hindi, and then you can see all of this. It's also pretty difficult if you don't know the language to go back and change it. So make sure you know or take a screenshot before you do that. So you can also go to layout preview just to check if you know you're doing the right thing. If you change it from Pixel XL to Nexus 7 from Nexus 7 to Nexus 4. Nexus 4 picks the default value because its width is lesser than 600 dp, but Nexus 7 has a width of more than 600 dp, so at that point, it's just going to pick that up. So it's a good way for you to figure out. You can also do the same thing with languages, because it lets you switch between your default language and other languages that you have set in your resource system. So you don't have to run it on different devices and change your app settings. So how does Android do this? So there is a whole process in finding the best match. Oops. Here we go. So we talked about configurations and qualifiers and this table that exists. So you can add these configuration and qualifiers to each of these the resource systems. So you have drawable, layouts, strings, and so on. This is the table. There's about 21 of them. It starts with mobile country code. And you can notice that all the qualifiers are over here: English, EN, and then smallest width, available width, screen size, port and land, and LDPI to TVDPI, and so on. So this is important to remember because you have to lay out these qualifiers in the right way. So if you say drawable HTTPI, that's fine. If you say drawable port HTTPI, that's fine too, because port comes above HTTPI in the table. If you say layout small H600 dp, that's wrong, because small comes after H600 dp. And you can't do drawable region Espanol and region English, because it has to be only for one locale. So either drawable region English or drawable region Spanish. So how does Android find the best match? Say you have a Nexus 7. It has screen orientation port, screen density XHDPI, large screen size, screen aspect is not long, and then the locale is English in the region US. So there's a flowchart here. First, it eliminates all the qualifiers that contradict your device configuration. Then it identifies the next qualifier in the table. And does it check, do any of these resource directories use these qualifiers? If yes, then it continues with this process until one directory is left. If no, then it identifies the next qualifier in the table. So going back to our device specifications, and if we have resources set up like this on our Android project, then the first thing that it picks up here would be layout Spanish large. And this is because that ES comes first in the table. And then the next thing it picks is the width, 720 dp. Then it picks not long. Finally, it picks port. And finally, if none of these things match, it goes down to layout, which is the default. So one of these things that you have to remember is that you need to identify your breakpoints. It can vary for different companies. Maybe you don't want to support like these 5,000 devices or different screen sizes. Maybe you just want to support particular type of devices. But it makes sense for you to identify your breakpoints. In our case, the breakpoint that we use to identify which, when the layout should change is we've actually identified 6 of them. So you have layout, which is the default value, and that's for portrait. Layout land, which is for landscape. Layout width 600 dp is anything, like a phablet, anything between phone and tablet. Layout width 600 dp land, and then layout width 1024 for tablets, and layout width 1024 dp land. And you can make these decisions using Material IO devices and the Material Designed Responsive UI. So this is what we've been doing in the Drama Fever app. These are our default states on portrait and landscape. And landscape, you notice that we're hiding the image view because we don't have enough space to show it. With 600 dp, what we've actually modified is just the margins. And we didn't have to copy-paste the layouts. All we did was change the dimensions. We created a dimension 600 dp that had, say, 40 dp in there. So that way, we're just fiddling around with the margins. Same thing with the breakpoint 1024 and portrait. But in landscape, because we have a lot more real estate here, this is a tablet, we have moved some things around, and we actually have a different layout here. So essentially, there are just 2 layouts, one which is default, and we're just messing around with the dimensions, and the second one, which is layout 1024 land, which is for this particular screen. So any device which has a width 1024 and above and is in landscape will pick the second layout. So now you're able to support multiple screens. You don't have to copy paste the same thing. You could create like 1 or 2 default layouts and then make sure that you just find the common element and just use any of the simple values to support multiple screens. So last thing I want to talk about is what's new in Android O. There's new things that have been added to the resource system. First is the fonts in XML. Previously, you could not support fonts in XML. You had to use calligraphy, which is a library written by Chris Jenkins, so that you were able to add fonts directly in XML. But now you can do that. This is yet another resource directory that you can create. So you can go to create new resource directory, create a font, and this is only available in Android Studio 3.0. And once you do that, you can download your TTF files. TTF files are for your fonts, and you can copy paste that into your fonts resource directory, and then create a new font family called Railway in this case, because we're using the Railway font, and you can directly add fonts in XML. So here's the Railway XML file. You add the fonts in here, Railway medium, and whatever else you want to add. And notice that in this case, we're using the app namespace because this can be backported. If I remember correctly, it's still 14, API level 14. And then you can add font to XML. So you can just do Android font family and do add font Railway, and you're all set. You can also add font to style. So say you want all the header text in your app to be font Railway, then you can do that. If you want all the subheader text to be font Open Sans, then you can do that. And finally, you can add font to the code by just doing typeface and then getting whichever font you want to use. So this is me experimenting with different types of fonts. The first one is Railway, and you can you know that as Railway because the W is very distinct. And the last two are Open Sans. And I've laid out baseline grid on top of it to see how much space how much width it's going to take, like what the font size is. One more thing is downloadable fonts. This is another cool thing. You can use this if you want to reduce your APK size. If you don't want to package all these TTF files, you can do that. One thing to note is that not all devices support this. So you need to make sure that there's always a default font in there, because the first time your app launches, it actually has to be online to get this downloadable font. The reason you would want to use downloadable fonts is that if you have a font that you're using in your app, and maybe a bunch of other apps are also using the same font, then all of you don't have to package the same font in there. So there is an option to add the font to the project as well. So you always need to have a default font in there. So to add downloadable fonts, just click on a text view and scroll down in the attributes. You could find font family, and then in more fonts, click on that. You'll be able to add downloadable font. So auto-sizing text views. Another cool thing you couldn't do before. So in this, you can make sure that you can scale by setting auto-size text type as uniform. The default is none. You can actually scale uniformly on both horizontal and vertical axes. So if you want to use it before 26, make sure to use the app namespace. And the default dimensions are like this. Minimum text size is 12, maximum is 112. And the granularity could range from 1 pixels to how much ever you want it to be. So as I was experimenting with this, I did not realize that I should be using wrap content or a fixed width or a height. I was just using match parent, and there was a lot of weird things going on. So in the first case, the height is 160 dp. So the text is able to scale in that space, in the 160 dp height. In the second case is about 240 dp, and the text actually, there's the same text, but it was able to pick up a size that fit into that height. You can do the same thing with presets, and this is where we would use arrays.xml. So create an array called auto-size text sizes, go in here and create all these presets ranging from 48 to 112. And notice that in this case, I used a height as 160 dp, and it actually clipped it. And when I used a height of 240 dp, it was able to show all of it. So you need to be very careful when you do this, and you need to experiment with this a lot more, because you're not sure how this is going to render on your different devices. So that's it. So you've learned a lot about resources and resource types. There's not just the basic 4 that you get, there's many more. You can support multiple screens using qualifiers, and you know how Android finds the best match. And you can also make sense for you to identify your breakpoints. So also what's new in O is that there's fonts now supported in XML with downloadable fonts. And you can also auto-size text views. So here are all the references I've used. It's a lot of fun reading through all of this. If you're a font geek like me, well, it is a lot of fun. And that's it. If you have any questions, I'll be around here, or you can catch me at the party later on. Thank you so much.